Hello students, in this video we are going to discuss Cbse class 9 physics chapter 10 work and energy. We are seeing the fifth part, and in this we will be discussing the derivation of potential energy and kinetic energy. So we saw in the previous video about potential energy and kinetic energy. So potential energy is the energy possessed by a body by virtue of its position, or we can say at rest. Okay, the energy possessed at rest, that you call it as potential energy, or you can call it as stored energy. So here, while you are going to pull back a rubber band, when you pull it back, you are going to store some energy, and when you release it, kinetic energy is being done. So that is this, the first thing is potential energy. Here you see that he is pulling back, so some energy is stored, and when it is getting released, it's going to go out as kinetic energy. So the more the bow is pulled back, the greater the potential energy. So all these things we discussed in the previous video. Even here, when you move up and down, you can see that. So in this stage you will have kinetic energy, and here also you will have kinetic energy, but in the top you will have the stored energy or the potential energy. So potential energy can be gravitational, chemical, nuclear, elastic, electric. So in all these ways it can be. And next is your kinetic energy, is the energy by virtue of its motion. Okay, so it is by virtue of its motion, and here we have few examples of kinetic energy. So when you have potential energy and kinetic energy together, you call it as mechanical energy. Is it clear, children? So this is what we discussed previously. So these are the various types of kinetic energy also. Just go through it: shooting a rubber band, water falling over the fall, a yo-yo, and even a bow and arrow. Okay, so next we are going to see the mathematical derivation of kinetic energy. So to do the mathematical derivation of kinetic energy, we are considering an object of mass m moving with an initial velocity u, and it is going to attain a final velocity v after moving through a distance s. So we know what is kinetic energy. Kinetic energy is nothing but the work done on it to acquire that velocity. So as I told you in the previous videos, energy and work done are the same. Okay, so energy, it can be written as W, or it is going to be force into displacement. And for force, from Newton's second law, I can write it as F is equal to ma. And we know from the third equation of motion that v square equal to u square plus 2as. From this we can write it as v square minus u square is equal to 2as, or I can write s is equal to v square minus u square by 2a. So that is what we have here. And now we have f, and then we have s. So you can substitute these both in this equation number 1. So when you substitute there, you are going to get ma into v square minus u square by 2a. So a and a will get cancelled. So this will be half m into v square minus u square. So this equation will hold good when the object is going to move with some initial velocity u. What if an object is going to start from rest? Then u will be equal to 0. In that case, we'll get kinetic energy to be half m v square. So this is how you will do the mathematical derivation of kinetic energy, children. So please read this very clearly. You will be using this in even in your higher classes. So this is regarding potential energy. Next, so when you see potential energy, so we have the stored energy. So we are considering a motion like this, wherein you carry a object to a particular height h. Okay, so in that particular height, you can see that the object is going to have the stored energy or the potential energy. So now let's get into the derivation. So we are considering the ball on top of a building of height h. So here you can see there is some work done on the ball. So the ball has some energy when the ball is being lifted. How is the ball lifted? The ball is lifted against the gravitational force. Okay, so you can see that the ball is going to have the gravitational potential energy. Now again we are going to do the same thing similar to the kinetic energy derivation. That is, we are going to consider the Newton's second law. So F is equal to what? M into A. But here, since we are using the gravitational force, instead of A, we are going to replace it by G. So it's going to be M into G. Okay. So F is equal to what? M into G. Now we are seeing that W is equal to F into S. Here we have found out F. Now what is S? S is the height it has traveled through, and the height which it can again travel back. What height can it travel now? At this particular height, it can again travel this entire height, that is going to be h. So we have F to be m into g, and then you have h. So this mgh is the formula for potential energy. So for potential energy, it is going to be mgh. So for kinetic energy, it is going to be half m into v square minus u square, or we can write it as half mv square for an object at rest. Is it clear, children? So with this we have discussed the mathematical derivation of potential energy and kinetic energy. Hope you have understood this, children. If you have any doubts in the concepts of energy, work, potential energy and kinetic energy, please go through the previous 4 parts from this playlist, children. Hope you understood this. We'll go through the next concept in the upcoming video. Thank you, children.